Welcome back to Weekend Dev Challenge 35. This is part 2 and we are seeing the Iris 3D Mapper project. So in this we have to, we have the Iris, typical Iris data set. So we have to identify and we have to check if we can visually identify the clusters of the species in 3D space and how do petal and sepal, dimensions interact and how does the terrain of petal width look like. Alright, so this might sound confusing. Let's jump into the code so you'll understand properly. So first we have the you know uh, load iris dataset again df equal to p.read csv with the file path would be mentioned, that is iris.csv, and we check if the dataset is loaded, and if it is not loaded then we throw an exception saying error loading data and whatever that particular error is. Now the next function we have is plot feature distribution. So you have to create a 2 by 2 grid of histograms to show distribution. So certain histograms we are creating 2 by 2. So first histogram is up for sepal length in centimeter, and then followed by sepal width in centimeter, and then sepal petal length in centimeter, petal width in centimeter. So then we have certain axis of whatever it is, 0 0 0 1 1 0 1 1, and then tight layout is basically to make it fit inside that 2 cross 2 grid, and then we save it as iris distributions.png. Now after that we have the 3D scatter and this line plot. So now here we have to first mark the figure so that is 10 by 8, and then we have to create the 3D axis. So this projection equal to 3D gives us the 3D axis, and then we have the colors whatever we want, and then here for the scatter plot we have to select the group. First is the sepal length centimeter, sepal width in centimeter, and petal length centimeter. This is x, y, and z axis respectively, and then we have the opacity 0.6 and certain stuff. Now after that we have the numerical columns which we can't put on this thing from before calculating mean, which we have to remove. So those numerical columns are sepal length centimeter, like all these 4 columns are the numerical. So we drop this ID and species, so that particular 2 non-numeric columns before calculating mean, because if for non-numeric columns you can't calculate mean, so we are just removing that, and then we are keeping only the numerical columns. Then we have to plot for the means of sepal length, sepal width, and petal length. Then add the label particular respectively, whatever the label it is for that particular sepal length, sepal width, or petal length. And then we have the iris 3D scatter.png, saving it as iris 3D scatter.png. Now the next function is plot contour map. So what is this? Basically this is to represent the elevation using petal width. So we have the axis that is 10 by 6, and we have the x-axis and y-axis that is sepal length and sepal width. Z-axis would be petal width. Again, this is also a 3D. And then here we have the levels equal 14 and CMAP equal to infinite, whatever the features they are with the x, y, z. And then we have the color bar. So basically we have a color bar to represent the elevation. And then we have the plot. Basically the main scatter plot is, we have mentioned all the details of that particular scatter plot. And then we have the axis. We have labeled the axis following by the title. And then we have saved it as iris contour map.png. So then we have in the main function we have called all the functions created previously. Alright, so now we have the project ready. Okay, first would be iris distribution. So this is the 4 histograms. Yeah, so you can see the 4 histograms. One is sepal length, sepal width, petal length, and petal width. Then we have the iris 3D scatter. So you can see how it is scattered on the 3D space for all the 3 particular species. Then we have the contour map. Alright, so this is the contour map. So you can see again petal width elevation followed by the elevation. Basically that is what this is used for. Let me submit the program. So the test case is passed, and I'll see you in the next video. Thank you.